Ladies and gentlemen, we will continue without transition with a case study on an interesting topic: new trends in streamlining manufacturing operations, best practices in industrial digital. This case study will be presented by Mr. Karim Purak, founder and CEO of Process Miner. Mr. Purak is a technology entrepreneur leveraging over 25 years of hands-on experience in product design, software development, and commercialization. The fields of his expertise include data analytics, machine learning, automation, industrial process optimization, just to name a few. I will not tell you more. Please, let's welcome on stage Mr. Karim Purak.
Good afternoon, everyone. My name is Karim Purak. I'm the CEO and co-founder of Process Miner. I'll just go directly into the use case. Process Miner is a US-based company. Our specialty is process optimization using an AI platform that can optimize the quality of a product being made on the machine in real time, as well as optimize the consumption of the raw material being used during the manufacturing process. If you look at any continuous or semi-continuous manufacturing process, typically there's the machinery and the raw material input into that machinery, as well as the operators and quality assurance folks that work in these facilities to make sure that the quality of a product is up to the target. And it can be actually done, the quality testing could be done manually. It could be done using robots, vision systems, and other methods to make sure that the quality of a product made at the end of the line is near the target and is satisfactory to be shipped to the customer. Typically, when the product is made at the end of the line, the quality people test the product, and if the quality is not near the target or is not satisfactory, they communicate that with the operating team, and they ask for adjustment to be made to the machine and make correction to that quality. It's very, very reactive concept. So in this concept, which is very traditional and seen around the globe on many different manufacturing verticals, there's a lot of wastes happening because it's a trial and error, essentially. There are standard operating procedures that followed, but based on the dynamic nature of the process, those standard operating procedures are not going to apply to make a good product every time. And in this process, including just the waste of a product and raw material, there's a lot of waste of energy, water, and other materials that goes into the process. Typically on these machines, if there are data collected, this data is being sent into a data historian or SCADA system. This data can be produced from a variety of different sensors, IoT devices, and different data producers on these machines. And what we do at Process Miner, we collect a subset of this process data in real time, and we continuously predict the quality of a product coming out of the machine. So imagine if an operator is testing the product every 45 minutes to an hour, we predict that quality every 30 seconds. The benefit of that is that we continuously can see the trend of the quality while it's being made. So we are transforming the whole reactive method into a proactive method. And we can start predicting the quality pretty accurately. And then when the trend of the quality deviates from the target, up or down, the system, the AI system, automatically makes adjustment to the machine. And I'll give you an example of that. If you look at the chart on a right-hand side, the blue, this is a wet tensile quality. It's the quality of a paper that when they make it, when they manufacture it, has to be set to a target. There is a target of 1100 for that particular product. The blue line, the blue curve and blue bars are when an operator is optimizing the machine to make good quality product. Good quality product means the product that are adhering to the target. They are very near the target. And if the green dotted line in that same chart depicts our platform optimizing the quality of a product in real time. As you see, we are improving the quality by over 60% when our autonomous control system does that, reducing the variation of the quality by over 20%. But we're not only looking at making a more optimal quality product. We also help our customers reduce the consumption of the raw material that is used to make that product. Chemical that's used into the process, fiber, resin, or any raw material that goes into a recipe to make the product. On the left chart is a chemistry in this case. This is a real use case. It's a chemistry that directly impacts the quality that I explained on the right-hand chart. This chemistry, when the dosing changes, it directly impacts that quality. So the blue line again is the sort of a presenting the when the operator manually optimizes the machine and the quality by dosing this particular chemistry. And the dotted green line and the green bars are when our platform autonomously optimizes the machine to consume and dose this chemistry into the system. As you see, we are continuously reducing the chemistry that used for this particular quality by over 25% for our client. This results in a significant saving for our clients. So in terms of making a better quality product, reducing their waste, as well as increasing the quality, right, and reducing the chemistry usage and other usage in other raw material usage, including fiber. On the left-hand side, as we are continuously measuring our KPI for our customer, we are demonstrating that we cumulatively, in this particular case, delivering over $1.5 million value to our customer by just reducing the consumption of the chemistry as raw material to the system. On the right-hand side, you see the chart that continuously shows every month how much of this chemistry we are reducing for this customer. We are sending these reports on a continuous basis to our customer in terms of a quality improvement, as well as what we have saved them on the raw material consumption, as well as making a better quality product. But alongside that, another very important functionality that our platform delivers to our customer is our very extensive AI-driven root cause analysis. As you see this chart, the red lines are upper and lower limit for a particular quality parameter, and the dots and the graph are presenting the test that was done manually by operators there. So if you see one of these tests that an operator sees that it is dipping or spiking, they can click on it, and our system in real time can tell them that what are the most influential variables and the reason that this problem has happened to their machine. They can further investigate by looking at that particular variable in their process and see exactly what happened. Where is this problem is coming from, right? So all these activity happening on the machine by consuming real-time process data, as well as being able to autonomously close the loop, meaning that our platform can continuously in real time optimize multiple quality parameters at the end of the line, as well as multiple inputs to the machine, and autonomously optimize and controls that. This not only upskills the operators and giving them a lot of different tools to perform their work better, but also allows them more time to tend to more other competing priorities. So we are not only just providing the capability of making more optimal quality products, we also create an autonomous control system that can optimize their machine in real time, hands-free, and give them time back to do other work. All right, with that, I'll take any questions from the audience. The question is, for this system to work, you need a lot of data to be collected at a long time. You need an adequate amount of data to be collected for a right amount of time. So typically, we ask our customers for training data that it's 6 to 12 months from their process, assuming they have sensors on their machine and they're collecting data there. And what we do, we can even get 3 months, depending on how much of this data is being consumed. But we have had customers also that when we started with them, we collected their data for 2 months and then started building the model for them as well. Great question. So it's about the security. Obviously, everyone is concerned about the cybersecurity. Our platform has 2 different offerings. One is a cloud agnostic offering, meaning that we can run on any cloud, including AWS, Azure, Google, and your own private cloud within your infrastructure, as well as we have an on-prem system that we essentially provide a server that you can put within your own network that is disconnected from internet from outside and can do the same type of capability on that. So it addresses the cybersecurity question. The question is if the system is connected to the internet. No, the system can run on-prem on the server by itself. So it's an on-prem, fully sort of a on-prem platform. Only we can connect it to the internet with the supervision of the client for maintenance, and that's temporary. But other than that, it doesn't need to be connected to the internet for it to work. Yes, sir.
Yes, thank you for the informative presentation.
Sure.
I would like to ask about the margin of error of this system.
About
the margin of error? It has like a margin of error, like human error? Or
yeah, every system has a margin of error, but I think what you're referring to is on a prediction side of things, right? Predictions in general, when you do a continuous every 30 seconds prediction, you're not looking at the point prediction margin of error. It's about the trend that prediction continues. So you're not talking about one prediction. One prediction could have a small margin of error, but the trend of that actually diminishes that margin of error. So it always works very accurately. However, in our system, we actually have it on our dashboard. We continuously monitor our own performance, our model's performance, to make sure that we are providing the best value. Now, one of the very unique things about our platform is this. Because the nature of manufacturing process is very dynamic, our platform actually continuously changes the model on the process to make sure to give you best performance there. My time's over? All right. Thank you very much. I'm here if you have any questions. Please stop by. Thank you.